Somewhere in the vast silence between galaxies, something may already be forgetting you. Not metaphorically, not poetically, literally. What if the universe, the same one that gave birth to stars, time, and consciousness, is slowly erasing its own memory, piece by piece? And what if we are next? Because there are strange clues hidden in history, physics, and the very structure of reality, clues that suggest something unsettling. Not everything that existed still does. And worse, not everything that disappears is meant to. So before this moment fades, before this thought itself slips into nothing, stay with me, because what you're about to hear might already be disappearing. Before we go deeper into this mystery, take a second. If you're drawn to stories that make you question reality itself, hit like. It helps this kind of content survive in a world that's always moving too fast. Subscribe if you haven't yet, because most people who watch never come back. And in the comments, tell me where you're watching from, or what you do in your daily life. It's strange, but grounding ourselves in reality might matter more than we think. Now, let's begin. There was no single moment when humanity realized something was wrong. No alarm rang, no voice echoed across the sky. It was quieter than that. Subtle, like a word on the tip of your tongue that never arrives. Long before telescopes and satellites, before equations and observatories, the earliest humans looked up at the night sky not just with wonder, but with familiarity. The stars were not random to them. They were anchors, stories, maps carved into darkness. Every light had meaning. Every pattern was remembered. And for thousands of years, that sky remained their most reliable constant. Until, slowly, it didn't. Ancient astronomers and civilizations separated by oceans and languages, Babylonian, Egyptian, Chinese, each recorded the positions of stars with astonishing precision. These weren't guesses. They tracked movement, brightness, cycles. Their survival depended on it. But hidden within those records are peculiar inconsistencies. Not errors, absences. There are stars that appear in early charts that no longer exist in later ones. Not faded, not dimmed, gone. And not in the way stars usually die. No recorded explosion, no supernova lighting up the sky, no slow decay noted over generations. Just missing. At first, these gaps were dismissed. Transcription mistakes, lost manuscripts, human error. But the deeper historians dug, the stranger it became. Different cultures, separated by vast distances, seemed to agree on the existence of certain celestial objects, objects that modern astronomy cannot account for. It's as if something was once there, seen, recorded, depended upon, and then removed so completely that only fragmented memories remain. And memory, as we know, is fragile, but not this fragile. Imagine navigating the ocean using a star that has guided your people for centuries, only for it to vanish within a generation. Not drift, not dim, disappear. Would you question the sky or yourself? This is where the unease begins, because it wasn't just the stars. The earliest mythologies of humanity are filled with gods and beings whose roles seem incomplete. Entire deities appear in one era, only to be erased from later traditions as if they never mattered. Their temples crumble, their names are scratched out, their stories abruptly end mid-narrative. In some cases, historians have found references to gods with no surviving myths at all, only mentions of their existence. A name without a story, a presence without a trace. It's like opening a book and finding entire chapters missing, but no sign that they were ever torn out. And what's more unsettling is how naturally people seem to accept it, as if forgetting was part of the process. There is an ancient Chinese record from the Han Dynasty that describes a guest star appearing suddenly in the sky, bright enough to rival the moon. It lingered for weeks and then vanished. Now, in modern astronomy, we would call that a supernova, a massive stellar explosion. But here's the problem. There is no known remnant, no expanding cloud of gas, no neutron star, nothing in that region of space that corresponds to such an event. It's as if the explosion happened and then erased itself. Even more curious are the records that don't describe something appearing, but something disappearing. One fragmented Babylonian tablet describes a star used for agricultural timing that could no longer be found. The text doesn't speculate, it doesn't panic, it simply notes the absence and adjusts, as if the sky itself had quietly rewritten the rules, and humanity adapted. But adaptation doesn't mean understanding, it means surviving without answers. There's a story told among early Polynesian navigators, masters of the open ocean, about a star that betrayed them. For generations, it had been a fixed point in their mental maps, guiding voyages across thousands of miles of empty sea. Then one season, it wasn't where it should have been. Or worse, it wasn't there at all. Some dismissed it as miscalculation, others believed it was a warning from the gods, but a few whispered something else, that the sky had changed, not shifted, changed. And if the sky can change, then what else isn't permanent? This is where the line between observation and fear begins to blur. Because humans are incredibly good at rationalizing the unknown. We create stories, we fill gaps, we smooth over inconsistencies until reality feels stable again. But stability can be an illusion, especially when the changes are small enough to go unnoticed in a single lifetime. Think about it. If something disappeared today, something vast, something distant, something you only glance at occasionally, would you notice immediately? Or would it take years, decades, generations before someone realized it was gone? And by then, who would remember what it looked like? This is the true danger of slow disappearance. It doesn't shock. It erodes, quietly, relentlessly, until absence feels normal. There's a haunting pattern that begins to emerge when you look at ancient records, not as isolated artifacts, but as a continuous narrative. Things appear, things are recorded, things are relied upon, and then things are gone. Not with drama, not with explanation, just gone. And the most unsettling part? The records themselves seem to forget. Later texts don't mention the missing stars, they don't question the lost gods, they don't mourn the vanished reference points. It's as if the absence itself is absorbed into reality, as if whatever disappears takes the memory of its importance with it. And that raises a question that feels almost too strange to ask. What if forgetting isn't just something we do? What if it's something that happens to reality itself? Because if the universe has a kind of memory, if it stores information in the arrangement of matter, energy, and time, then what happens when that memory begins to fail? What happens when the record starts to break down? The ancient world may not have had the language to describe it. No equations, no theories of entropy or information loss, but they had something else: observation and intuition. They noticed when something felt off, when patterns broke, when the familiar became uncertain. And while they may have explained it through gods or fate, the underlying experience was the same. Something was missing, and no one knew why. As centuries passed, these anomalies were buried under layers of interpretation. Myths evolved, records were rewritten, the gaps were filled with stories that made sense within the worldview of the time. But the original inconsistencies never fully disappeared. They lingered, like echoes of something that once was. And perhaps that's the most chilling part of all. Not that things disappeared, but that the universe allowed us to almost forget that they ever existed. Almost. Because every now and then a fragment surfaces, a record that doesn't fit, a memory that doesn't align, a star that should be there, but isn't. And in those moments the illusion cracks, just enough to glimpse something deeper, something unsettling, something that suggests this isn't random, this isn't error, this isn't just the past being imperfectly recorded, it's something else, something quieter, something patient, that doesn't erase everything at once, but slowly, carefully, systematically, until the only thing left is the feeling that something is wrong, without any memory of what was lost. And as we move forward in time, into an age of telescopes and data, of satellites and digital archives, you might expect these mysteries to disappear, to be explained, to be resolved. But they don't. In fact, they get worse. Because now, for the first time in history, we have the tools to notice disappearance in real time. And what we're starting to see is far more disturbing than anything the ancients could have imagined. Because the sky isn't just changing anymore, it's forgetting. And this time, we're watching it happen.
There is a quiet assumption we all live with, that memory is a kind of storage, a place where moments are kept, preserved like files in a cabinet, accessible, stable, real. But that assumption is wrong. Memory is not storage. It is reconstruction. Every time you remember something, you are not retrieving it, you are rebuilding it. Piece by piece, emotion by emotion, detail by detail. And in that process, something subtle happens. It changes. Not dramatically, not enough to alarm you, but enough. Neuroscientists have discovered that each act of remembering slightly rewrites the memory itself. It's as if the brain opens a file, edits it unconsciously, and saves it again. Over time, the original version is gone, replaced by something close enough to feel true, but no longer exact. Now imagine that happening not just in a human mind, but across reality itself. Because if memory is fragile within us, what about the universe? We often think of the universe as a perfect recorder, every event, every interaction, every particle movement etched into the fabric of space-time. Physics, after all, is built on the idea that information persists, that nothing is truly lost. But that idea is under threat. Let's start small. Think about your earliest memory, not the one you've been told about, but the one you feel is yours. How certain are you that it happened exactly the way you remember it? The lighting, the voices, the sequence of events. If someone challenged it, if they showed you evidence that parts of it were wrong, would you accept it? Or would you defend the memory? Because here is the unsettling truth. Confidence is not accuracy. And the brain doesn't prioritize truth. It prioritizes coherence. A consistent story is more important than a correct one. That's why false memories can feel just as real as true ones. Entire events can be implanted, altered, or erased without us noticing. People have been convinced they experience things that never happened, simply through suggestion and repetition. Now take that principle and scale it up. What if reality itself behaves similarly? What if the universe doesn't store information perfectly, but instead reconstructs it over time, smoothing inconsistencies, filling gaps, prioritizing continuity over precision? Suddenly, the idea of things being forgotten doesn't sound so impossible. It sounds inevitable. In physics, there's a concept that sits at the edge of understanding, the idea that the universe is fundamentally made of information, not matter, not energy. Information. Every particle, every force, every interaction is a kind of data, encoded in the structure of reality. This is not science fiction. It's a serious line of thought in modern physics. But it leads to a disturbing implication. If reality is information, then it can degrade. Just like any system that stores data, the universe would be vulnerable to noise, loss, corruption. And if that happens, what we call reality might not be as stable as we think. There's a phenomenon in cognitive science known as memory decay. Over time, unused memories fade, not because they are actively erased, but because the connections that hold them together weaken. The brain, in a sense, lets go. But here's the strange part. Sometimes when a memory fades, we don't notice its absence. We don't think, I've forgotten something important. We simply move on, unaware that anything is missing. Now consider this. What if the universe does the same? What if information doesn't just disappear with a dramatic event, but quietly fades, becoming less accessible, less defined, until it effectively no longer exists. And what if, just like with human memory, the system adjusts? Imagine a detail in reality, something small, something rarely referenced, beginning to degrade. Its influence weakens, its connections to other parts of the system loosen. Eventually, it slips out of the network entirely, and when it does, everything else shifts slightly to compensate. The story remains coherent, but something is gone, and no one notices. This idea might sound abstract, but there are hints of it even in our own experiences. Have you ever felt certain that something used to be different, but you can't prove it? A line in a movie, the spelling of a word, the way a place looked when you were younger. You feel the discrepancy, but when you check, reality disagrees. So you assume you're wrong. But what if you're not entirely wrong?
What if you're remembering a version of reality that no longer exists? This is where the boundary between psychology and physics begins to blur. Because if memory is reconstruction and reality is information, then both are subject to change. And the more complex the system, the harder it is to detect those changes. The human brain contains around 86 billion neurons, each forming thousands of connections. The number of possible configurations is staggering. Yet even in that complexity, memory fails. Now consider the universe. Billions of galaxies, trillions of stars, countless interactions happening every second. If even a tiny fraction of that information were to degrade, the effects could be subtle, diffuse, almost impossible to trace. A missing star here, an inconsistent record there, a feeling that something doesn't quite add up, but nothing definitive, nothing you can point to and say, this is where reality broke. Because the break doesn't look like a break, it looks like normal. This is the most insidious aspect of memory failure, whether human or cosmic. It doesn't announce itself, it integrates. It becomes part of the system it alters, and over time, the altered version feels just as real as the original, perhaps more so. There's a reason we trust our senses, our memories, our perception of continuity. Without that trust, we couldn't function. But that trust may be misplaced. Because if the universe is capable of losing information, and all evidence suggests that it might be, then what we experience as a stable, continuous reality could actually be a constantly updating reconstruction, a best guess, a version that works, even if it's not entirely accurate. And if that's true, then the question isn't just whether things can be forgotten, it's whether they already have been, and whether we've adapted so completely to those losses that we no longer recognize them as losses at all. Think back to the ancient records from the previous chapter, the missing stars, the erased gods, the silent adjustments. At the time, those were anomalies. But what if they were early signs of something much larger, a process that has been unfolding for thousands, perhaps billions of years? A slow erosion of information, a gradual thinning of reality's memory. And we, living in the present, are not outside of that process. We are part of it. Our memories, our histories, our observations, they are all embedded in the same system. If the system changes, so do they. Which means that even our attempt to understand what's happening could be affected. We might be asking the wrong questions, or missing the right ones entirely, because the clues we need may already be gone. This is where the discomfort deepens, because it's one thing to accept that memory is imperfect. It's another to consider that the foundation of reality itself might be subject to the same flaws. And yet, the evidence, subtle, fragmented, easy to dismiss, continues to accumulate. Not in a way that proves anything conclusively, but in a way that creates a pattern of disappearance, a pattern of inconsistency, a pattern that suggests something is not being preserved as it should be. And if information is the most fundamental layer of reality, then its loss is not a minor glitch, it's a fundamental breakdown. But here's the paradox. If something is truly forgotten, completely erased from the system, then by definition there is no record of its existence, no evidence, no trace, which means we would never know. Unless something slips through, a fragment that doesn't align, a record that shouldn't exist, a memory that refuses to fit the current version of reality. Those are the moments that matter, the anomalies, the glitches, the small cracks in the narrative, because they might be the only evidence we ever get that something was lost. And as we move from the fragile memory of the human mind to the vast memory of the cosmos, those cracks begin to widen. Because out there, beyond our atmosphere, beyond our planet, beyond even our galaxy,
We are starting to see something that doesn't just suggest forgetting, it suggests removal. Objects that were once observed, precisely measured, carefully recorded, and are now simply not there. No decay, no transition, no explanation, just absence. And this time we have the data, which makes the question impossible to ignore. What does it mean? When the universe forgets something we can still prove once existed. Because that's exactly what we're about to explore next.
In the modern world, we trust our instruments more than our instincts. Telescopes don't forget. Satellites don't misremember. Data doesn't dream. At least, that's what we've always believed. Because unlike the ancient observers who relied on naked eyes and memory, today's astronomers record everything. Light from distant stars is captured, measured, cataloged, archived across multiple systems, verified by independent observatories across the planet. If something exists in the sky today, we can prove it tomorrow. And if it changes, we can track the change. That's the promise of modern science. But over the past few decades, something has started to challenge that promise in a way that is deeply unsettling. Not because it's dramatic, but because it's silent. It begins with a simple expectation. Stars don't just disappear. They evolve, they expand, they collapse. Sometimes they explode in brilliant supernovae that can outshine entire galaxies for weeks. When that happens, we see it, we record it, we study the aftermath, the expanding shells of gas, the neutron stars, the black holes left behind. Even in death, stars leave evidence. But what happens when there is no death? No explosion, no remnant, no trace at all. Just a star that was there, and then isn't. At first, this sounds impossible, and for a long time it was treated that way. When astronomers compared old photographic plates of the sky, images taken decades ago, with modern digital surveys, they expected to see the same stars, perhaps slightly shifted due to motion, perhaps dimmed or brightened, but still there. Instead, in some cases, they found nothing. Not a faint remnant, not a displaced object, nothing. A point of light that had once been clearly recorded, bright enough to be measured, catalogued, and confirmed, had vanished, completely. At first, these cases were dismissed as errors. Dust on the lens, defects in old film, misidentification of transient events like asteroids or variable stars. But as more data was analyzed, the pattern became harder to ignore, because some of these missing stars didn't behave like any known transient object. They weren't moving, they weren't flickering, they weren't temporary. They were stable until they weren't. One of the most striking efforts to investigate this phenomenon came from a project known as VASCO, Vanishing and Appearing Sources During a Century of Observations. Its goal was simple: compare 100 years of sky surveys and identify objects that had appeared or disappeared without explanation. What they found was unsettling. Out of millions of stars, a small number showed no clear correspondence between past and present observations. Objects that should have been there were gone, and in some cases, objects that weren't there before had appeared. Now, science demands caution. Extraordinary claims require extraordinary evidence, so researchers look for every possible conventional explanation: instrumental error, data corruption, atmospheric distortion, misclassification, and in many cases those explanations held, but not all. A few anomalies remain stubbornly resistant, and those anomalies carry a disturbing implication. Because if even one of those disappearing objects is real, not an error, not a misinterpretation, but an actual star that ceased to exist without leaving a trace, then something fundamental about our understanding of the universe is incomplete. Stars are not supposed to vanish. They are governed by physics, by mass, energy, gravity, nuclear fusion. Their life cycles are predictable, even if complex. There is no known mechanism by which a star can simply stop existing, not without a process. Not without a signature, not without a story we can read in the data. But here we are, with gaps, with absences, with points in the sky where something used to be, and now there is only darkness. And perhaps more unsettling than the disappearance itself is how easy it is to overlook. Think about the scale we're dealing with. The Milky Way alone contains hundreds of billions of stars. The observable universe contains hundreds of billions of galaxies. If a handful of stars go missing, it barely registers. It's like losing a grain of sand on a beach. But what if it's not just a handful? What if it's happening more often than we realize, and we simply don't have the resolution to detect it at scale? What if disappearance is not an anomaly, but a low-frequency feature of reality? This is where the mind begins to stretch uncomfortably. Because once you accept the possibility that something can vanish without a trace, you have to ask, what determines what disappears? Why those stars? Why not others? Is it random? Or is there a pattern we haven't yet recognized? Some have proposed exotic explanations, unknown forms of stellar collapse, interactions with dark matter, hypothetical processes that convert matter into forms we cannot detect. Others have ventured into more speculative territory, ideas that sound like science fiction, but are difficult to completely dismiss. What if advanced civilizations are capable of engineering stars and removing them? What if what we're seeing are not natural events, but interventions? But even those ideas, as extreme as they are, still assume something important, that the star goes somewhere, that it is transformed, relocated, hidden. But what if that assumption is wrong? What if the star doesn't go anywhere? What if it is not moved, but erased? Not in the sense of being destroyed, but in the sense of being removed from the fabric of reality itself. It sounds impossible, because it challenges the very principle that underpins modern physics, the conservation of information, the idea that information about a system, its state, its structure, cannot be completely lost. And yet, the universe has a way of confronting us with scenarios that force us to reconsider our most basic assumptions. Because there is already a place where this principle is under threat, a place where information may not be preserved, a place where the rules begin to break down. Black holes. When something falls into a black hole, it crosses a boundary known as the event horizon. Beyond that point, it cannot escape, not even light. From the outside, we can no longer access the information about what fell in. For a long time, physicists believed that this information was effectively lost, that the black hole erased it. Later, new theories suggested that the information might be preserved in subtle ways, encoded on the surface of the event horizon, or released slowly through radiation. But the debate is not fully settled. And that uncertainty matters, because if there exists even one mechanism in the universe that can truly erase information, then the idea of disappearance without trace is no longer unthinkable. It becomes possible. And once it's possible, you have to ask whether it's happening elsewhere, not just in extreme environments like black holes, but in the open sky, in the stars we thought we understood. Because the Vasco anomalies are not black holes swallowing stars in dramatic events. They are quiet, unannounced, undetectable in the moment, only visible in hindsight when we compare what was to what is, and notice that something doesn't match. This is the same pattern we saw in ancient records, but now the difference is we have instruments, we have timestamps, we have data, and still, we have gaps, which raises a chilling possibility. What if the universe is not just failing to preserve information, but actively using it? Not in a catastrophic way, not in a way that tears reality apart, but in a slow, distributed process. Small losses, scattered across space and time, each one insignificant on its own, but together, forming a pattern of forgetting. Because that's what this begins to look like. Not destruction, not transformation, forgetting. The star was there. The universe knew it was there, encoded in light, in gravity, in the interactions with surrounding matter. And then, at some point, that information is no longer accessible, no longer part of the system, no longer real. And just like with human memory, the system adjusts. The surrounding stars continue their motion. The galaxy remains stable. The equations still work. Everything appears normal, except for that one absence, that one missing point, and the quiet question it leaves behind. If something as massive, as energetic, as fundamental as a star can disappear without a trace, then what else can? Because stars are not small things. They are anchors of structure, sources of light and heat, drivers of cosmic evolution. If they are not immune to whatever process is at work, then nothing is. Not planets, not systems, not even observers. And that's where this stops being an abstract mystery and starts becoming something personal, because we are made of the same fundamental components of those stars. We are patterns of information, organized in a particular way, sustained over time. If the universe is capable of losing information at the scale of stars, then at what scale does it stop? Or does it stop at all? As we move deeper into this investigation, we leave behind the comfort of classical physics, the idea that everything is predictable, traceable, conserved, and we enter a domain where one of the most basic assumptions begins to fracture. The idea that once something exists, it always leaves a trace. Because if that assumption is wrong, then the implications reach far beyond astronomy. They reach into the nature of reality itself, into the question of whether anything is truly permanent,
and into a paradox that has troubled physicists for decades. A paradox that sits at the heart of black holes, and may hold the key to understanding whether the universe can truly forget. Because if information can disappear, then reality is not just changing, it's unraveling, and we're only just beginning to notice.
There is a rule in physics so fundamental, so deeply woven into our understanding of reality that we rarely question it. Information cannot be destroyed. Not energy, not matter, not the arrangement of particles that defines a system. Even when something changes form, burns, breaks, collapses, the underlying information about what it was is preserved in some way. This principle is not just a guideline. It is the backbone of predictability. Without it, science itself begins to lose its footing. Because if information can vanish completely, then cause and effect break down. The past no longer guarantees the future. Reality becomes unreliable. For a long time, this wasn't a problem. Every observation, every experiment reinforced the idea that information, though it might become scrambled or difficult to retrieve, was never truly lost. Until physicists began to study one of the most extreme objects in the universe, black holes. At first glance, black holes seem simple. They are regions of space where gravity is so intense that nothing, not even light, can escape once it crosses a boundary known as the event horizon. From the outside, a black hole appears as a dark void, defined only by its mass, charge, and spin. Everything else is hidden. And that's where the problem begins. Imagine throwing a book into a black hole. Not just any book, one filled with information, words, images, meaning, a specific arrangement of matter that encodes a story. As the book approaches the event horizon, something strange happens. To an outside observer, it appears to slow down. Its image stretches, redshifts, fades. And then it's gone. From our perspective, the information in that book has crossed a boundary from which it cannot return. It is no longer accessible. Now, you might think, that's fine. The information is still inside the black hole, just hidden from us. But here's the twist. Black holes are not completely black. In the 1970s, physicist Stephen Hawking proposed that black holes emit a faint form of radiation, now known as Hawking radiation. Over incredibly long periods of time, this radiation causes black holes to lose mass and eventually evaporate completely. Which leads to a disturbing question. When the black hole is gone, where does the information go? If the book fell in and the black hole eventually disappears, what happens to the information that defined that book? Is it somehow encoded in the radiation? Or is it gone? For decades, this question has divided physicists. It's known as the black hole information paradox. On one side, the laws of quantum mechanics insist that information must be preserved, that even if it becomes scrambled beyond recognition, it cannot be destroyed. On the other side, the behavior of black holes seems to suggest the opposite, that information can cross a boundary and be lost forever. Both cannot be true, and yet both are supported by our best theories. This is not a minor inconsistency. It is a fracture at the foundation of reality. Because if information can truly be destroyed, if it can be erased without a trace, then the universe is not a perfect recorder. It is something else, something fallible. To understand why this matters, we need to look deeper at what information actually is. When we say information, we don't just mean data in a computer or words on a page. We mean the complete description of a system, the exact position and momentum of every particle, the precise arrangement that makes something what it is. In theory, if you had complete information about the universe at one moment, you could predict its entire future. That's the dream of classical physics, a deterministic universe. But that dream begins to unravel if information is not preserved. Because even a small amount of information is lost, the chain of causality breaks. The future becomes less predictable. The past becomes less certain. Reality becomes fuzzy. Now consider this in the context of what we've already seen. Missing stars, gaps in ancient records,
subtle inconsistencies that don't quite fit. Individually, they might be dismissed, but together, they begin to form a pattern that echoes the black hole paradox. A pattern where information seems to vanish. Not just hidden, not just transformed, but gone. There are physicists who argue that the paradox has already been resolved. That information is not destroyed, but encoded in ways we don't yet fully understand. Perhaps on the surface of the event horizon, in a kind of holographic representation of reality. This idea, known as the holographic principle, suggests that everything inside a volume of space can be described by information encoded on its boundary. It's a beautiful concept, elegant, but it raises its own questions. Because if information is stored on boundaries, then what happens when those boundaries change? When they shift, collapse, or disappear? Is the information still preserved? Or does it degrade?
And even if information is technically preserved, what if it becomes so scrambled, so diffused, that it is effectively lost? From a practical standpoint, there may be no difference between information that is destroyed and information that can never be recovered. To an observer, both are indistinguishable. Both appear as absence. And that brings us back to the central tension. Because what we're seeing in the universe, the anomalies, the disappearances, the inconsistencies, don't look like information being preserved in some hidden form. They look like information being removed, cleanly, completely, without residue. It's as if reality is not just storing and evolving information, but occasionally deleting it. And that idea is deeply unsettling, because deletion implies something different from natural processes. It implies a change in the rules, or a failure of the system, or something even harder to articulate, a process that we don't yet have the language to describe. Think about a digital system, a computer, for example. Files are created, modified, stored. Over time, they can become corrupted. Bits flip, data degrades. But there is also another possibility, deletion. A file can be removed entirely, leaving no trace in the active system. Unless you have backups, logs, or some form of redundancy, it's as if the file never existed. Now imagine a universe without backups, without external storage, without a higher-level system preserving its state. If information is deleted, there is nowhere else for it to exist. It is not hidden, it is not recoverable, it is simply gone. And if that can happen even once, then the assumption that reality is stable, continuous, and fully traceable begins to break down. Because we rely on that assumption not just in science, but in our understanding of existence itself. We assume that what happens leaves a mark, that our actions, our histories, our presence are recorded in the fabric of the universe. But what if that's not always true? What if there are moments, events, objects, even entire structures that are removed so completely that no trace remains? No evidence, no memory, no record? From the outside, reality would appear consistent, coherent, but it would be missing pieces, pieces we would never know were gone, unless, occasionally, something doesn't quite fit. A paradox, a contradiction, a small crack in the logic, like the black hole information paradox, a place where our theories collide and something gives. Because paradoxes are not just problems to be solved, they are signals, indications that our understanding is incomplete, that something deeper is happening beneath the surface. And the black hole paradox may be more than just a theoretical puzzle. It may be a window into a broader truth, that the universe is not a perfect archive, that information is not always preserved, that under certain conditions, reality itself may be capable of forgetting, not metaphorically, not poetically, but physically. And if that's the case, then the disappearances we've been exploring, the missing stars, the gaps in history, are not isolated mysteries. They are symptoms, signs of a deeper process at work, a process that operates quietly without fanfare, a process that doesn't announce itself with explosions or catastrophes, but with absence, with silence, with the subtle removal of things that once were. And as we continue forward, the scope of that process begins to expand, because it's not just stars and abstract information that may be affected. It's not just distant objects or theoretical constructs. There are patterns in human history, entire civilizations, technologies, and knowledge systems that seem to appear and then vanish in ways that don't fully make sense, as if parts of our past have been thinned out, simplified, forgotten. And if information can be lost at the cosmic level, then perhaps it can be lost at the human level as well, not just in individual minds, but in the collective memory of our species, which leads us to a question that is both historical and deeply unsettling. What if we have already forgotten things that we were never meant to lose? And what if the evidence is still there, hidden in the gaps of our own past? History is often described as a story, a long, continuous narrative stretching from the earliest humans to the present day, a chain of cause and effect, where each generation builds upon the knowledge of the last. But when you look closely at that chain, it doesn't feel continuous. It feels broken. There are gaps, not small ones, not the kind you expect from incomplete records or lost documents, but deep, unsettling voids, periods where knowledge seems to surge forward and then collapse. Civilizations rise with astonishing sophistication and then vanish, leaving behind fragments that don't quite add up. And the more we uncover, the more a disturbing pattern begins to emerge. Because some of these civilizations don't just disappear, they leave behind evidence that suggests they knew more than they should have for their time. Take ancient Mesopotamia, often called the cradle of civilization. It gave us writing, law, mathematics, but embedded within its earliest records, especially in Sumerian texts, are descriptions of astronomical observations that seem unusually precise. They chart planetary movements. They describe celestial cycles with a level of detail that feels advanced. Of course, historians explain this as the result of careful observation over long periods, and that's likely true. But then there are anomalies, descriptions of objects or alignments that don't match our current understanding of the ancient sky, references that appear once and are never mentioned again, as if something was known and then quietly forgotten. Now move forward to ancient Egypt, a civilization that built monuments so precise, so enduring, that even today we struggle to fully replicate them. The pyramids, aligned with cardinal directions to an astonishing degree, structures that seem to encode knowledge of geometry, astronomy, and engineering far beyond what we would expect from a society without modern tools. Again, there are explanations: incremental development, lost techniques, skilled labor over generations, but there are also questions that remain unanswered. Why do some of these structures appear suddenly in history, fully realized, highly sophisticated, without clear evidence of the gradual learning process that should precede them? Where are the failed attempts, the transitional forms? Why does it sometimes feel like knowledge appears fully formed, and then, just as mysteriously, it disappears? Consider the Indus Valley Civilization, one of the largest and most advanced urban cultures of the ancient world. Planned cities, complex drainage systems, standardized weights and measures. And then decline, not through a single catastrophic event, but a gradual fading. Cities abandoned, systems forgotten, and most strikingly, a script that we still cannot decipher. Thousands of inscriptions exist, but their meaning remains locked away. It's as if an entire layer of knowledge is just out of reach, visible but inaccessible, like a memory you can almost recall but not quite. Now shift to Mesoamerica, the Maya, a civilization that developed a calendar system so precise it could track celestial cycles with incredible accuracy. They understood eclipses, planetary motion, long-term astronomical patterns. Their knowledge of time itself was profound, and yet much of it was lost. Codices burned, cities abandoned, knowledge fragmented. What remains is impressive, but incomplete, always incomplete. And that's the pattern. Not total erasure, not a clean slate, but fragmentation. Pieces left behind. Enough to hint at what was once there, but not enough to fully reconstruct it. It's like finding pages of a book scattered across time, each one filled with meaning, but missing the context that ties them together. And as we gather those pages, we begin to sense that something is off, because the gaps don't always feel natural. They don't always align with the expected processes of decay, conquest, or environmental collapse. Sometimes they feel selective, as if certain kinds of knowledge are more likely to be lost than others. Practical knowledge, how to farm, how to build basic shelter, tends to persist. It's reinforced daily, passed down through necessity. But abstract knowledge, astronomy, mathematics, symbolic systems, deeper understandings of time and structure, seems more vulnerable, more prone to disappearance. Why? One explanation is simple: complexity. The more complex a system of knowledge, the easier it is to lose if the conditions that support it collapse. But that doesn't fully explain the pattern, because even within surviving civilizations, we see knowledge being forgotten.
techniques that are no longer understood, methods that cannot be replicated, ideas that are referenced but not explained. It's as if the thread of understanding has been cut, leaving behind only the surface. There's a story often told about ancient Roman concrete, structures built over 2,000 years ago that have endured far better than many modern equivalents. For a long time, the exact composition of this material was lost.
The Romans knew how to make it. Later generations didn't. The knowledge wasn't destroyed in a single event. It simply faded until it had to be rediscovered. Now multiply that by entire fields of knowledge, entire systems of thought, entire ways of understanding the world, and you begin to see the scale of what might be missing. Because history is not just what we remember, it's also what we've forgotten. And the unsettling possibility is that we've forgotten far more than we realize. There are moments in the archaeological record that feel almost like interruptions, sites that suggest a level of organization or capability that doesn't quite fit the surrounding timeline, artifacts that appear out of place, not in the sense of being impossible, but in the sense of being ahead. And then, instead of leading to further development, those threads go cold. No continuation, no evolution, just silence. As if the knowledge didn't spread, didn't propagate, didn't survive. This is where the question becomes difficult, because we can explain individual cases, war, climate change, resource depletion, cultural shifts, all valid, all supported by evidence. But when the pattern repeats across different regions, different eras, different cultures, it begins to feel less like isolated incidents and more like a systemic tendency. A tendency for complex information to be lost, to degrade, to slip through the cracks of time. And if we connect this to what we've already explored, the fragility of memory, the possibility of information loss at a cosmic level, the idea becomes even more unsettling, because it suggests that history itself may be subject to the same forces, not just human forgetfulness, but something deeper, something embedded in the structure of reality, a process that doesn't target specific civilizations or ideas, but operates universally, quietly reducing the total amount of accessible information over time, like entropy, but applied to knowledge. And if that's true, then the gaps in our history are not just accidents. They are symptoms, evidence of a slow erosion, a thinning of the past, where each generation inherits a slightly reduced version of what came before, not enough to collapse civilization, not enough to trigger alarm, but enough to ensure that certain things are never fully recovered, never fully understood, always just out of reach. And that leads to a haunting thought. What if the most advanced knowledge humanity has ever possessed is not in our future, but in our past, lost, not in a dramatic fall, but in a gradual fading, a forgetting so complete that we don't even know what questions to ask, because the questions themselves may have been forgotten. This is where history begins to feel less like a record and more like a shadow, a projection of something fuller, richer, more complex that we can no longer fully see. We study what remains. We piece together fragments. We build narratives that make sense of the available evidence. But there is always that underlying tension, that sense that something is missing, something important, and we don't know what it is, because if we did, it wouldn't be missing. As we move forward, this pattern of forgetting becomes even more personal, because it's not just ancient civilizations or distant stars that show signs of inconsistency. It's us, our own memories, our own shared experiences. There are moments where large groups of people remember something one way, and reality insists it was always another, not in minor details, but in ways that feel too consistent, too widespread to dismiss entirely. This phenomenon has a name, and it may be one of the most direct clues we have that something is shifting, not just in the past, but in the present. Because if reality can lose information, then the boundary between what was and what is remembered may not be as stable as we think. And that's where things start to get truly strange.
There's a moment most people have experienced, small, almost trivial at first. You remember something clearly, not vaguely, not as a guess, clearly. A line from a movie, a brand logo, the spelling of a familiar word. It feels fixed, certain, unquestionable. And then you check, and it's wrong. Not slightly off, not a minor detail, completely different. At first, you assume it's just you, a lapse in memory, a simple mistake. But then you mention it to someone else, and they remember it the same way you do. And then another person agrees, and another, until you realize something strange is happening. A group of people, sometimes thousands, sometimes millions, share the exact same incorrect memory. Not similar, identical. This phenomenon has come to be known as the Mandela effect, named after the widespread false memory that Nelson Mandela died in prison in the 1980s, despite the fact that he was released, became president, and lived until 2013. At first glance, the explanation seems straightforward. Human memory is flawed. We are influenced by suggestion, repetition, cultural overlap. We misremember, we simplify, we fill in gaps. And that's true. But the Mandela effect introduces something more unsettling, because these aren't random errors. They are patterns, consistent, repeatable patterns, large numbers of people remembering the same alternative version of reality. Take the famous line from the movie Star Wars Episode 5, The Empire Strikes Back. Many people remember it as, "Luke, I am your father." It's iconic, recognizable, embedded in pop culture. But that's not the actual line. The line is, "No, I am your father." And yet, across generations, across countries, across people who have never spoken to each other, the same incorrect version persists. Why that version? Why not dozens of variations? Why such precise consistency? Or consider the children's book series, The Berenstain Bears. Some remember it as Berenstain Bears. Others insist it was always Berenstain. When people check, they often feel a jolt of discomfort, not because they were wrong, but because it feels like reality has shifted, as if the version they grew up with has been replaced. Again, the standard explanation is memory distortion. Our brains prefer familiar patterns. Steen is more common than stain, so we unconsciously adjust it. Simple, logical. But then the pattern expands. Logos that people remember differently, historical details that seem to shift, lines from books, scenes from films, even geographical features that feel off. Each case on its own can be explained, but together they form something harder to dismiss, a kind of collective glitch. And that's where the discomfort deepens, because the Mandela effect is not just about being wrong. It's about the feeling that something was once right and no longer is. A subtle but persistent sense that reality and memory are not perfectly aligned. Now, from a psychological perspective, this can still be explained. Memory is reconstructive. We've already seen that. It changes over time, influenced by external inputs, internal biases, cultural reinforcement. But there's a limit to how far that explanation can stretch before it begins to feel incomplete, because the Mandela effect is not random. It doesn't affect all memories equally. It clusters around specific types of information, cultural artifacts, shared experiences, widely recognized details, things that exist not just in individual minds, but in the collective memory of society. And that's important, because collective memory behaves differently from individual memory. It's reinforced through repetition, media, conversation, shared experiences. It becomes part of a larger network of information, distributed across millions of minds. In theory, that should make it more stable, more resistant to distortion. And yet, it isn't. In some cases, it seems almost synchronized in its deviation. Large groups of people remembering the same alternate version, as if they all experienced a slightly different reality. Now, there are several ways to interpret this. The most grounded explanation is that these are examples of convergent memory errors, different people arriving at the same incorrect version due to similar cognitive processes. Our brains simplify, generalize, and standardize information. We create mental shortcuts. And when enough people use the same shortcuts, the same errors emerge. This is supported by research. It's the safest explanation, the one that fits within our current understanding. But it doesn't fully address the emotional weight of the experience, because when people encounter a Mandela effect, they often describe a specific feeling, not confusion, not uncertainty, but certainty, followed by dissonance, a sense that something is wrong, not with their memory, but with reality. Now, that feeling can be misleading. Humans are not perfect judges of truth, but feelings often point to something deeper. Not necessarily that the memory is correct,
but that the system producing the memory is encountering something it can't easily reconcile. And that brings us back to the broader theme: information, memory, reality as a system of stored and reconstructed data. If the universe itself is subject to information loss, or even subtle alteration, then the boundary between what was and what is remembered could begin to blur. Not in obvious catastrophic ways, but in small, distributed inconsistencies. exactly like the ones we see in the Mandela effect. Now, to be clear, this does not prove that reality is changing. There is no definitive evidence that timelines are shifting or that we are moving between alternate versions of the universe. Those ideas are speculative, interesting but unproven. What we do have is something more grounded and perhaps more unsettling. Evidence that human memory is not a reliable archive, and that even our most shared, reinforced memories can diverge from recorded reality. Which means that if something were to change, if information were to be lost or altered, we might not notice it directly. We would notice it indirectly, through discrepancies, through that feeling of, this isn't how I remember it. But without a stable reference point, we would have no way to confirm it. We would default to the simplest explanation, that we are wrong. And in many cases we are. But what if not always? What if occasionally those discrepancies are not just errors, but traces? Residual artifacts of something that has changed. Something that no longer exists in the current version of reality, but left an imprint in memory. A kind of echo. It's a difficult idea to accept because it challenges a fundamental assumption. That reality is consistent across observers. That what is true for one person is true for all. But the Mandela effect introduces a subtle crack in that assumption. Not a break, not a contradiction, just a small inconsistency. A place where shared experience and recorded fact don't perfectly align. And that inconsistency becomes more significant when viewed alongside everything else we've explored. Ancient records with missing elements, stars that vanish without trace, information that may not be fully preserved, history with unexplained gaps. Each one on its own can be explained, but together, they begin to form a pattern where information is not perfectly stable, where memory, both human and cosmic, is subject to change, where reality may not be a fixed, immutable record, but something more dynamic, more fluid, more vulnerable. And if that's true, then the Mandela effect is not just a curiosity. It's a symptom, a small human-scale manifestation of a much larger process, a process that operates across scales, from individual minds to entire civilizations to the fabric of the universe itself. A process that doesn't announce itself with dramatic shifts, but with subtle inconsistencies, small enough to be dismissed, frequent enough to be noticed, unsettling enough to make us question something we rarely question, not just what we remember, but what is real. Because if reality can change in ways we don't fully perceive, if information can be lost or altered without leaving clear traces, then the world we experience may not be a perfect reflection of what has always been. It may be a version, a reconstruction, a current state of a system that is constantly evolving, and possibly slowly forgetting. And as we move deeper into this idea, we leave behind the realm of psychology and perception. We return to physics, to time itself. Because if there is a process that governs the loss of information, it may be tied to the most fundamental direction in the universe, the arrow that moves everything forward, the one thing we all experience, but never fully understand: time. And what if time is not just the passage of events, but the mechanism through which the universe forgets?
There is a direction to everything. You feel it without thinking. A glass falls and shatters, but the pieces never rise back into place. A fire burns wood into ash, but ash never becomes wood again. You grow older, but never younger. This direction has a name: time. And for as long as we've tried to understand it, we've described it in terms of motion, past to present, present to future. But that description is incomplete, because time doesn't just move, it transforms. At the heart of that transformation is a principle that governs the entire universe: entropy. In simple terms, entropy is often described as disorder, the tendency for systems to move from order to chaos. But that's only part of the story. A more precise way to understand entropy is this. It is the measure of how much information is spread out, how much detail is lost in the description of a system. When something is highly ordered, it contains a lot of specific information. Every piece is in a precise place, every part contributes to a clear structure. When entropy increases, that structure dissolves. The same components are still there, but their arrangement becomes more random, more diffuse, harder to describe in detail. The information isn't necessarily destroyed, but it becomes inaccessible. Imagine a pristine book. Every word, every sentence carefully arranged. It tells a story, rich with meaning. Now imagine shredding that book into millions of tiny pieces and scattering them across a vast field. Technically, the information is still there. Every letter still exists, but the story is gone. Not because it was erased, but because it can no longer be reconstructed. That is entropy, and it is always increasing. This is known as the second law of thermodynamics, a principle so reliable that it underpins everything from chemistry to cosmology. It gives time its direction, because as entropy increases, systems move from states that are easy to describe to states that are not, from clarity to ambiguity, from memory to forgetting. And that's where the idea begins to shift. Because if entropy is the spreading out of information, then time itself may not just be a measure of change. It may be the process by which the universe loses its ability to remember. At first, this sounds abstract, but consider what happens on a cosmic scale. In the early universe, shortly after the Big Bang, everything was incredibly hot, dense, and uniform. As it expanded, structure began to form: particles, atoms, stars, galaxies. This increase in structure might seem like a decrease in entropy, but globally, entropy was still rising. Energy was spreading out, becoming less concentrated, less available for doing work. Over billions of years, stars burn their fuel, galaxies drift apart, and the universe becomes more diffuse, more uniform, more quiet. Physicists sometimes refer to the ultimate fate of the universe as heat death, a state where entropy has reached its maximum and no meaningful structure remains, no gradients, no energy differences, no processes, just a vast, uniform expanse. At that point, nothing happens, because there is no longer any information to process, no structure to evolve, no memory to preserve. Now, that's the extreme end of the timeline, trillions upon trillions of years in the future. But the process that leads there is happening right now. Every moment entropy increases. Every moment information becomes slightly more spread out, slightly harder to recover. And if we reinterpret that process not just as disorder, but as forgetting, then time itself begins to look like a slow erosion of reality's memory. Not an abrupt deletion, not a sudden collapse, but a gradual fading. The sharp edges of information soften, details blur, distinctions dissolve, until what remains is simpler, more uniform, and less defined. This perspective changes how we think about the anomalies we've been exploring: the missing stars, the gaps in history, the inconsistencies in memory. What if these are not separate phenomena? What if they are all manifestations of the same underlying process, a process driven by entropy, a process that doesn't just affect energy and matter, but information itself? Because if information becomes too diffuse, too scrambled, too entangled with everything else, then from any practical standpoint, it's gone. And that might explain something important, because the disappearances we've been discussing don't look like sudden, high-energy events. They don't leave dramatic traces. They don't announce themselves. They are subtle, quiet, almost invisible. Exactly what you would expect from a process that operates gradually, diffusely across the entire system. Not targeting specific objects, but affecting everything, everywhere, all at once. Of course, entropy alone doesn't fully explain everything. It doesn't tell us why certain anomalies appear more pronounced than others. It doesn't account for the specific patterns we sometimes see.
But it provides a framework, a direction, a reason why information might not be perfectly preserved over time. And it introduces a deeper question. Because if entropy is the natural tendency of the universe, then why does anything persist at all? Why do structures, stars, galaxies, life exist in the first place?
The answer lies in local pockets of order, regions where energy flows in such a way that complexity can emerge and sustain itself, at least temporarily. Earth is one of those pockets. Fueled by the sun, it maintains low entropy locally, allowing life and memory to exist. We are, in a sense, temporary resistance to the overall trend. We build structures, we record information, we preserve history, we create meaning. But we do so against the current, and the current is relentless. Over time, every structure breaks down, every record degrades, every memory fades. Even the most durable materials, stone, metal, digital storage, are subject to entropy. Given enough time, everything we've ever created will be lost. Not violently, not dramatically, but inevitably. And that includes us, not just our bodies, but our thoughts, our experiences, our entire existence as a pattern of information. Now, here's where the idea becomes more personal. Because if time is the process of forgetting, then the present moment is not just a point between past and future. It is the only place where information is fully intact, the only moment where reality is at its most detailed, its most defined. As soon as a moment passes, it begins to degrade, not instantly, not completely, but gradually. Memories form, but they are imperfect. Records are created, but they are incomplete. The full richness of the moment is lost. This is something we feel intuitively, the sense that the past is less vivid than the present, that memories fade, that details slip away. But we usually think of this as a limitation of our minds. What if it's not? What if it's a reflection of a deeper truth, that the past itself is less defined, that information is not preserved with perfect fidelity as time moves forward, that reality itself becomes less precise? If that's the case, then the universe is not just moving towards disorder, it is moving towards simplicity, a state where distinctions are lost, where differences blur, where the complexity that allows for meaning, structure, and memory fades away. And that brings us back to the idea of forgetting. Because forgetting is not just losing information, it's losing the ability to distinguish one thing from another, to say this happened and that did not, to maintain a clear, detailed record of what was. As entropy increases, those distinctions become harder to maintain, and eventually, they may disappear entirely. Now, this doesn't mean that reality is collapsing around us in any immediate sense. The timescales involved are vast, far beyond human experience, but the process is continuous, and if there are mechanisms, unknown processes, interactions we don't yet understand, that accelerate or localize this loss of information, then the effects could become noticeable, subtle at first, but real. And that's where all the threads begin to converge. The ancient observations of missing stars, the modern anomalies in astronomical data, the gaps in history, the inconsistencies in memory. Each one can be seen as a small deviation from perfect information preservation, a tiny failure in the system. Individually, they are easy to dismiss. Collectively, they suggest something more, that the universe is not a perfect archive, that information is not guaranteed to persist, that time is not just a neutral backdrop, but an active process, a process that gradually, inevitably, reduces what can be known. And if that's true, then the question we're left with is not just about stars or civilizations or abstract physics. It's about us, because we are made of information. Our identities, our memories, our histories, they are all patterns encoded in matter and energy, subject to the same laws, subject to the same process, which means that, over time, we too are part of this slow erosion, not just physically, but informationally. The details that define us, our experiences, our thoughts, our existence, they will not persist forever. They will fade. They will disperse. They will become indistinguishable from everything else. And eventually, there will be no trace, no record, no memory, as if we were never here at all. Unless there is something that resists that process, something that preserves information beyond the reach of entropy, something that anchors existence in a way that prevents complete forgetting. And that brings us to the final question. Because if the universe is slowly forgetting, then what, if anything, can still remember us? And what happens when even might is gone?
There is a silence that comes at the end of every story, not the kind you notice immediately, not the kind that interrupts, but the kind that settles in slowly after the last word has been spoken, after the last memory has been recalled. A silence that doesn't just surround the story, but replaces it. Because every story depends on something fragile, a listener, a record,
a trace. Without those, even the most powerful narrative dissolves into nothing. And that brings us to the final, unsettling question. What happens when there is no one left to remember? Not just you, not just humanity, but anything. Because throughout this journey, we've followed a pattern, from ancient records hinting at missing pieces to modern observations of stars that vanish without explanation. From the fragility of human memory to the possibility that information itself may not be perfectly preserved. From the quiet inconsistencies of collective memory to the relentless force of entropy slowly eroding the structure of reality. Each step has led us here, to the edge of a question that feels almost impossible to hold on to. If the universe is capable of forgetting, then what becomes of existence when it forgets everything? At first, the answer seems obvious. Nothing. A complete absence. A final, irreversible erasure. But the more you think about it, the more complicated it becomes. Because nothing is not something we can truly comprehend. Every thought we have, every image we imagine, is built from something. Even the concept of emptiness is constructed from contrast, space without objects, silence without sound. But what we're talking about here is deeper than that. It's not just the absence of matter or energy, it's the absence of information. No records, no distinctions, no memory of what was. In that state, there is no before and after, no story, no observer. It's not that the universe is empty, it's that the idea of a universe no longer has meaning. And that's where the discomfort reaches its peak. Because everything we are, everything we value, everything we strive for, is built on the assumption that something persists, that our actions leave a mark, that our existence, however brief, becomes part of a larger tapestry. But what if that tapestry is not permanent? What if it is slowly unraveling, not violently, not catastrophically, but gently, thread by thread, until there is nothing left to hold it together? This is not just a scientific question, it's a philosophical one, a deeply human one, because it forces us to confront something we rarely consider, not just the end of our lives, but the end of our trace, the end of any evidence that we were ever here. Now, you might think this makes everything meaningless. If nothing is remembered, then nothing matters. But that conclusion is too simple, because meaning is not something that exists independently of observers. It's something we create, in the present, in the act of experiencing, understanding, connecting. Even if every trace of that meaning eventually fades, the experience itself is real. It happens. It exists if only for a moment. And that moment is not diminished by the fact that it won't last forever. But still, there's something unsettling about complete erasure, because it's different from death. Death ends the experience, but as long as there is memory, records, stories, traces, something of that experience persists. It becomes part of something larger. But if memory itself is not guaranteed, if information can be lost completely, then even that form of continuation is uncertain. And that brings us back to the idea that has been quietly building throughout this story, that reality may not be a perfect archive, that it may not preserve everything that happens within it, that it may, over time, lose pieces of itself. And if that's true, then the final question is not just about what is lost, it's about what remains. Because if everything is subject to forgetting, then what, if anything, resists it? Is there something in the universe that preserves information beyond the reach of entropy? Some fundamental layer that holds on to everything, even as the visible structure fades?
Or is forgetting absolute? Is there a point where even the possibility of memory disappears? Some physicists have speculated about the idea of a cosmic record, a way in which information might be encoded in the structure of reality itself, beyond what we can directly observe. Others suggest that information is never truly lost, only transformed into forms we cannot access. But these are theories, possibilities, attempts to reconcile the discomfort we feel with the idea of complete erasure. Because intuitively, we resist it. We want to believe that something remains, that the universe, in some deep way, remembers. But what if that desire is just that, a desire? What if the universe does not guarantee preservation? What if it simply evolves, and in doing so, lets go? Not out of intention, not as a deliberate act, but as a consequence of its own nature, a system that cannot hold on to everything forever, a system that, given enough time, simplifies, reduces, forgets. And if that is the case, then we are part of that process, not separate from it, not immune to it, but embedded within it. Our thoughts, our memories, our histories, they are all patterns of information, subject to the same laws. They persist for a time, they interact, they leave traces.
And then, gradually, they fade. But here's where the perspective shifts. Because if forgetting is inevitable, then remembering becomes something extraordinary. Every act of memory, every time you recall a moment, every time you tell a story, every time you preserve a piece of knowledge, is a kind of resistance, a temporary defiance of entropy, a way of holding on to structure in a system that is constantly trying to dissolve it. And that gives the present moment a kind of weight, a kind of significance, not because it will last forever, but because it won't. Because it is the point at which information is most complete, most detailed, most alive, right now, this moment. The thoughts you're having, the images forming in your mind, the questions that are beginning to take shape, they exist with a clarity that will never be fully recoverable again. Even seconds from now, something will be lost, a detail, a nuance, a feeling, not dramatically, but inevitably. And that is the nature of time, not just movement, not just change, but the gradual reduction of what can be known, the slow fading of information, the quiet approach of forgetting. And yet, here you are, aware, thinking, remembering. For now, the universe has not forgotten you. Your existence is encoded in countless interactions, neurons firing, light reflecting, matter arranged in a specific complex pattern. You are part of the current state of reality, fully present, fully defined. But the question remains, not just for you, but for everything. What happens when that state changes? When the information that defines you becomes less accessible? When the traces you leave begin to fade? When the last memory of you, anywhere in the universe, disappears? Does it matter? Does it change anything about the fact that you are here? Or is existence itself enough, even if it leaves no lasting mark? These are not questions with easy answers. They may not have answers at all, but they point to something important, something that sits at the intersection of science, philosophy, and human experience. The realization that reality is not just something we observe, but something that is constantly being shaped, preserved, and possibly forgotten, and that we are not just passive observers, we are participants, temporary, fragile, but real. And perhaps that's the final insight, not that the universe is slowly forgetting us, but that for a brief moment in its vast timeline, it remembers, through us, through our awareness, through our ability to observe, to question, to wonder. We are, in a sense, the universe remembering itself, a fleeting, complex pattern of information that reflects back on the whole. And even if that reflection fades, even if the memory does not last, the fact that it happened at all is something that existed, something that was real, even if, one day, there is nothing left to remember it. And as this thought settles, as the idea begins to fade into the background of your mind, consider this. If the universe is slowly forgetting, then this moment, this exact moment, where you are thinking about it, may already be slipping away, not gone, not yet, but becoming less defined, less precise, on its way to becoming just another fragment in a system that cannot hold on to everything forever. So the question is no longer just theoretical, it's immediate, it's personal, it's happening now. What will remain at this moment, when even the universe can no longer remember it?